Hello! This time I will do the homework with you. Yeah, let's do it. So this first question is about how you can use loops to make code shorter. So here I am manually running a whole bunch of ellipse statements. And what I'm noticing is the last three arguments here are always the same, but the first argument starts at 5 and goes to 50 counting by 5s. So if I wanted to do this same thing, but with less code using a loop, I could do something like this. For I equals, let's do it starting from 5. I is less than or equal to 50. I plus equals 5, which is the same thing as saying I equals I plus 5. I could say I plus equals 5, same thing. So now the value of I is going to take on each of these values in turn. It's going to start at 5, go up to 50 counting by 5s. So now I can say ellipse I 0, 10, 10, and that should do the same thing. Okay, let's look at this one. Here, what I'm noticing is that all the ellipse statements are in groups, and it looks like each of these groups is similar to what's happening over here. For each of these groups, is that true? Yeah, for each of these groups, the last three arguments seem to be the same, at least within the group, but the first argument is changing. So one thing I could do would be replace each one of these groups with a single if statement. With a single for loop. So this top group I could rewrite this way. Start at 0, go up to 30, skip by 10s, and then the second group I could do this way. Start at 0, go up to 30, skip by 10s, except this time, let's see, the second argument is going to be 10. There's a reason why I'm not just going on. We're gonna make this even shorter in just a second. So here, this group, start at 0, go up to 30, skip by 10s, so that part's the same, except now the second argument here is always 20. And then, so I'm sensing a pattern here. Here, the first argument, 0 to 30, skip by 10s, that's the same, but now the second argument is always 30. Okay, so let's group all of these together now. And we'll see what we can do. Whoops. All right. Just want to paste these all ends to end. This is why you don't program outside of an IDE. This is terrible. Okay. Okay, so look at this code now. Let's ignore the original ellipse statements. Let's pretend we're just looking at this and we want to make it shorter. What I'm noticing is the for loop is the same for all four of these for loops. And what's inside the for loop is the same for all four of the for loops. The only number that's changing is 0, 10, 20, 30. So what we could do is we could add another loop. So I'm looping this chunk of code 4 times. And specifically the values I want to loop over are, the first time through the loop I want this to be 0. The second time through the loop I want it to be 10, then 20, then 30. So let's write a for loop to do that. So for int second equals 0, second is less than or equal to 30, second plus equals 10. So the reason I called it second is because this int variable is going to represent this second input. So you can see it starts at 0, goes to 30, skipping by 10s, which is exactly what this second argument's doing. And now I can put this on the inside, and I'll make my formatting more consistent in a minute here. And so now this can say second. So I know a lot of people said that nested loops were tricky, and maybe this is not making you feel better about this. We will definitely go over nested loops slower and in more detail, probably in the first couple of weeks, maybe week 2, week 3. But the way to think about this is, for this outer loop, the second variable starts at 0, goes up to 30. And for each value that second takes on, we're going to do this entire internal loop. So when second equals 0, I is going to go from 0 to 30. So the I variable is going to go 0 to 30. Meanwhile, the second variable is just 0 the whole time. Then once we're done with this internal loop, we go back to the outer loop. The value of second increments, so now it's 10. And then we go through this whole inner loop all over again. So second is going to be stuck at 10, while the I value goes from 0 to 30. So this is a very short way. It's 1, 2, 3, 4, 5 lines of code to do what was originally, what's this, 4 times 5, so 20 lines of code. So this is the kind of gold standard for what we want to be able to do by probably week 2 or 3. This kind of thing is likely not to be in the quiz in week 1. But it's good to practice because, eventually you'll want to be able to do it. Okay, let's go on to problems I can actually program in the editor. So here it says, return rectangle. I give it a height and a width and a letter. So if I say return rectangle 2, 3a, 2 is the height, 3 is the width, a is the letter. And it's going to return a string that looks like this. Okay, that's interesting. So if I say return 3, 1 star, the height is 3, like that. The width is 1, so it's only 1 star wide, and the character is star. Okay, tricky. So I'm saying here, make sure it doesn't display anything. We're going to return a string that looks like this. Okay, let's jump in. So return rectangle height width string. All right, so I'm going to program by intention. What was it called? Return rectangle. I'm just going to go ahead and do those sample ones. So 1, 3 star. And so now I'll let IntelliJ create the method signature for me. So I hit Alt-Enter, create method. There it is. I want to return a string. I don't want to keep these as I and I1 because that doesn't mean anything. So this was width, this was height, and this was letter, I believe. Okay, so let's think this through in pseudocode first. If I want to return a rectangle, well, let's see. So I know that I'll need to be building up a string. So let's make string output start as nothing. So now I know I'll need to do something where I'm adding what I want to the end of output, one step at a time. It seems to me that an easy thing to do would be, let's think about it one row at a time. So let's do the first row, and then the second row, and then the third row. So let's see, how many rows do I have? That must be height. So let's make a loop. Well, here, let's do it in pseudocode. So for each row, let's make a variable, make row, and then we'll say output equals output plus row. And then maybe we'll need to go to the next line. So output equals output plus new line, something like that. So that makes sense. I'm going to loop over however many rows there are. I'm going to make each row as a string, and then I'm going to take that string and I'm going to put it on the end of output. But then I'm going to make sure that after I've put a row, my string has a new line character, which will take me to the next line of the output. So let's try and realize this in actual code now. So for each row, how many rows? There's height rows. So let's make a for loop. I goes from 0 to height. This is like the standard way of looping that many times. So if height was 4, I'd be saying go from 0 to 4. But since I has to be less than 4, that's actually 4 total repetitions, because I'm like, hold up your fingers now. When I equals 0, that's the first loop. When I equals 1, that's the second loop. When I equals 2, that's the third loop. When I equals 3, that's the fourth loop. And that's when it stops. All right, so I know that's what I'm doing. If I wanted to, I could have a helper method here. Let's try that. String row equals make row. Let's just pretend that that exists and is a thing, and we'll think about it in a second. So assuming that's a thing, I could say output equals output plus row, and then let's also add in the new line. And then at the end, I will return the output. Okay, so I think something like that should probably work. So now we just have to think what's involved in making the row. So each row is the same letter over and over and over again. And how many do we need? We need width. So if I'm thinking, if I want to make a helper method that will create the row string for me, the information it needs to know is it needs to know what's the width of the row and what's the letter that we want to be using. So I'm going to pass those two things as input. I'll let IntelliJ create the method for me. Here it is. I want to return a string. I'll call that width. I'll call that letter. Okay, so now I don't even have to think about this part anymore. Now all I have to think is, how do I make this many copies of this letter? So let's use the same pattern. Let's say string output equals nothing. Let's loop this many times, width times, and we'll say output equals output plus letter. So what I'm doing essentially is I'm taking letter and I'm adding it to the end of output this many times, and then at the end let's return output. Okay, so when we put it all together, make row is almost exactly the same as a problem from the previous problem set, which was, what was it called? Return n times, or like get n times or something. And once we have each row, we add it to the end of output, and then we return output at the end. This way of thinking, where you break your problem down into smaller pieces and you create methods to solve each of those pieces, this is, again, kind of the gold standard for how you want to think about programming. And it's not easy to do, and it's maybe not the way that you're thinking about programming right now, but that's why we're learning. Okay, let's test it. Result, and then, oops, result. All right. Boy, I hope it works. Yay. Okay, so this is 2 by 3. This is 1 by 3. Let's change this to be 1 by 5, and let's change this to be 6 by 2, just as like another quick test. 6 by 2 is working. 1 by 5 is working. Yay. All right, problem on Math.random. So a student mistakenly thinks this will return a value between 10 and 20, because here we've got 10 and here we've got 20, but it doesn't. Here's the way to think about this. You got to think about it in pieces. So Math.random is between 0 and 1. Let's think about the smallest thing it could be and work out what's the whole expression going to give you. And let's think about the largest thing Math.random could be, and then think about what's the whole expression. So if Math.random is 0, then what do we have? We've got 0 times 20 plus 10. So that's the same thing as 0 plus 10, which is 10. So when Math.random is its smallest value, this will be our minimum value that the entire expression could evaluate to be. Okay, so if Math.random is like not quite 1, 0.999999, what are we going to have? We'll have not quite 1 times 20 plus 10. Okay, so what's that going to be? That's going to be like 29.999, so it's like not quite 30. Remember, casting to int, though, truncates the decimal. So that means it chops off the decimal. So it doesn't matter that we can get very close to 30. We're still going to chop off the decimal. So 29 is the largest thing that this could evaluate to be. So thinking really carefully, step by step, through what's the smallest, what's the largest, what would they multiply to be, I think that's the right way to think out this kind of problem. All right, so now let's do it ourselves. Let's write a statement that generates a number between 180 and 200. So int val equals, I'll cast to int, math.random. So let's see, here's the way I'm going to think about it. I'm going to do smallest thing plus what I'd have to add to get to the biggest thing. So I know 180 is the smallest thing, so I think I'm going to start with 180 no matter what. And then if math.random is 0, then it doesn't matter what I'm multiplying it by here. The smallest value is still going to be 180. So the question is, what would I have to multiply this by in order to get 200 here? So let's see. Let's think about it. So the difference between 180 and 200 is 20. So let's think through, would it work if I multiplied by 20? So let's say math.random is as large as possible, so not quite 1, 0.999999. in that case, so if Math.random is 0.9999, I'd have 180 plus 0.9999 times 20, and that is, what's that going to be? That's going to be I don't know, I'm thinking about this so hard. That's going to be 199.99999. Because I'm not quite adding 20, right? I'm really adding like 19.99999 here. So this doesn't quite get us to 200. When I cast to int, that's just going to give me 199. So I think what I need to do is add 1 here, so that way I'm really adding potentially up to 200. All right, let's do the next one. Get random pair. So I've got a string array. I'm going to choose 2 random members and return what they are with a space in between them. So this is like a direct application of something that I had in the notes there. Let's do this. I'm going to create my test array. And then string result equals get random pair. Okay. So one thing I could do is generate 2 random indexes and then get the values and return them. So I could do this. Let's do it in the longest way possible, then we'll shorten it. So I could say int lock1 is math.random times array.length, and then string val1 is array lock1, and then I do that same thing. Oops. I do that same thing for the second location and the second value that we're getting from the array. And then I'd return val1 and then a space and then val2. So that works. What could be shorter than this? So I don't actually need the lock1 variable. I could do this. So that would let me generate the random number right there inside the square brackets. So let's do that same thing here. Okay, it's a little bit shorter. Another thing I could do is I don't actually need to store into val1, val2. I could have these be directly in the return statements. So I could do that. This is like maybe the shortest. I'm not sure it's my favorite. It's a little ugly. A different thing we could do would be this. Let's say get random from array. I'm going to write my own helper method here. So now I essentially just renamed this line as a new method called getRandom, where I give it an array and it returns a random element from that array. And so now for the pair, I could do this. Get random and then a space and then get random. I think this is probably my favorite answer for readability and for reusability. And I understand that you're probably not doing this yet, but again, like I want to try and show you what I consider to be best practices so that way you can start adopting them over time. All right, last one. From this problem anyway. Get random from last n. So the idea is we'll give it an array, we'll give it a number, and it will randomly select from the end of the array, but going back by this many. So it's like randomly select from the last 1 element in the array, or randomly select from the last 2 elements in the array. So it's randomly selecting from D or E. Here I'm randomly selecting from the last 3 elements in the array. Here I'd be randomly selecting from the last 6 elements, but 1, 2, 3, 4, 5. There's actually only 5 elements here. And I said that if n is larger than the length of the array, return empty string. So this one should return the empty string. All right, let's give it a try. I'm just going to go ahead and paste this straight into the editor. Oops. Oh dear. Okay, so this is an important thing to know. The quotation marks used in most editors are not straight quotation marks. there's something that's not recognized by the IDE, so let's go and replace them with regular quotation marks. Okay, cool. And then all right, so let's call this array, and let's call this n. Okay, let's think about this in pseudocode. So I know how to get a random element from the whole array, but what I need to figure out is how to get a random element from the last n. So I think what I need to do is I need to figure out first what's the location number of the first random thing I might return. The location number of the last random thing I might return is always the same. So let's just start there. Well, all right, let's think the whole thing through. So first location equals figure it out, and then last location is always whatever the last location in the list is, which is array.length -1, alert, -1, and then get a random value between first location and last location. And then once I have a random, let's say int, and then once I have a random int between the first location and the last location, then I just return whatever corresponds to that int. Okay, so I think I have a plan now. Let's try and execute the plan. So first location is going to be, all right, so this requires a little bit of thinking. If n equals 2, let's actually label the locations here so we can think about it more easily. And by the way, this is what you should be doing to solve the problem. This is not me like explaining retrospectively. This is how I would actually solve the problem. In fact, I am actually solving the problem because I haven't thought about this yet. So like in my head, I'm thinking like take the last number and subtract n. But I just want to make sure that that makes sense here. So the last location number here is 4. And if I'm trying to select from the last 2, 4 minus 2 would be 2. But that's clearly not the location of the last 2. So I know taking the last number and subtracting 2 isn't going to work. So that's why it's really important to go through with specific numbers, because it can help you catch off by 1 errors. Here's what I am noticing, though. I am noticing that this has a length of 5. And so if I take the length of the list and I subtract 2, 5 minus 2 is 3, and that gives me the location of the first thing in the last 2. That kind of makes sense. If length is 5 and I subtract n of 1, that gives me 5 minus 1 is 4 here, and that's e, which is the first location of the thing that I might want to return. So I think that all makes sense. So the first location is going to be array.length minus n. Last location we said was array.length minus 1. All right, so now let's get a random number between the first location and the last location. So random location, int, math.random. Okay, so I know I want to start with the first location and then add whatever the difference might be that would get us up to the last location. So I'm thinking last lock minus first lock, because this is the difference. And so if I'm starting with the first location, if I'm going to get to the last location, it's like I've got to add that difference. But we still got an issue. And like whenever you're doing code like this, again, like check it with actual numbers to make sure that it actually makes sense. So let's do it with this example. So let's say I got first lock is 3 and last lock is 4, okay? So what is this actually going to end up being? I'll have first lock is 3 plus math.random times 4 minus 3 is just 1. So that's 1. Is this possibly going to give me 3? So if math.random is 0, then yes, I can get 3. So it's possible for me to get the first location. What if math.random is 0.99999? 0.99999 times 1 is still 0.99999, but then that's going to truncate, so the largest value I can get is also 3. And that's a problem because I can't get my upper value of 4. So an easy solution here is let's add 1 on the outside. And now I'm sure, and now if we sort of think the example through again, now we can see that it will be possible for us to get that last location. If you're just watching the video and you're like, whoa, that was like a little fuzzy, it doesn't quite make sense to me, stop the video. Work it out on paper yourself. It's really hard to do just watching somebody else think it through. You got to really work the numbers yourself on a piece of paper for it to make sense. All right, and then, let's finish the problem. So I'll return, what? Array, random location. Okay, so testing this one, it's returning random values. So this isn't a very thorough, what I'm about to do is not a very, very thorough test. But it will be at least sort of a spot check to see is something totally insane happening. Here, let's actually let's make a loop that loops 10 times, because then we can see are any of the random values something that they shouldn't be. All right, so I'm looping 10 times and it's always giving me E, which is what I want. Here I should be randomly choosing between D and E, which I am. Here I should be randomly choosing between C, D, and E, which I'm not obviously, but let's try it again. It might just be that C never got generated. Yeah, so I can generate C. Oh, you know what I'm forgetting though? Oh, it's interesting that this isn't giving me out of bounds. 1, 2, 3, 4, 5. Okay. What I did say at the very beginning was, if n is larger than array.length, then return the empty string. So I'm putting that at the very top, because remember, if you hit a return statement, it exits right away. It doesn't keep going to execute the rest of this. So that was the last piece of the problem. All right. Okay, legitimately last problem. We're going to make a person class for use in imaginary and not very good dating app. The person object should have the attributes age, name, a Boolean for whether or not they're messy, like true, false, you are messy, and a Boolean for whether or not their date needs to match them in messiness, like if I'm a clean person, I only want to date a clean person, or if I'm a messy person, I only want to date a messy person. So that's what that Boolean means. True would mean their date needs to have the same messiness value as them, so either messy or not messy. And false would mean I don't care what the other person's like, they don't have to match me. Okay, so we should have methods, getter methods for all the attributes. We should have a toString so that we can display it nicely. And then canDate. Remember, these are methods that a person object runs. So if I'm a person object, if we have me.canDate another person, that's going to return true if I am able to date that other person. And so this is going to be determined based on age. So if I am younger than 14, I may not date at all. Return false. Otherwise, what we're going to do is we're going to look at my age and figure out what is the minimum and maximum acceptable dating age for somebody else who I could date. So what we'll do is we'll take my age, which will be secret, and then divide it by 2 and add 7, and that's the minimum age of someone I could socially acceptably date. We'll take my age, subtract 7, and double it for the maximum age of someone I could acceptably date. And so then all we do is check if this other person's age is inside that age range. And if it is, cool, it's acceptable for me to date them. Otherwise, I return false. So whether or not I'm a match, the first thing I need to do is look at the other person and run this canDate method to see, like, are our ages compatible? You know, like, am I able to date that other person at all? If the answer to that question is no, we can just return false right away. If the answer to that question is yes, we also have to check to see if my kind of messiness value is acceptable to them and if their messiness value is acceptable to me. So if either of us said that our date has to have the same messiness value as our own, I'll need to check to make sure that's true before saying, yes, it's a match. And then in the tester, we'll make some random people and like see who can date who. Let's do it. All right, so I've got a lot of extraneous crud here because this is like my just garbage project for doing test code. But let's make a person class. So here we have person. You might be tempted to do things like this. String name, int age, Boolean. Wow. Boolean messy, and then Boolean must match. I don't know what a good thing to call that is. So this is okay, but the problem is all of these are public. And for a whole variety of reasons, which I'll explain more thoroughly in class, you always want to make your attributes private unless you have a very specific good reason why you don't. All right, so there's that. I'm just going to let IntelliJ generate my constructor for me. Yay. I'm also going to let IntelliJ generate my getter methods for me. Okay, if you didn't know that was possible, be aware that is possible. So you can hit Shift and then search for what you want. So I searched for constructor, and that generated the constructor. For setters and getters, you can hit Shift, search for getter. If I wanted setters also, you could select this one, but I only wanted getter methods. So anyway, that's now created all the methods that I want. Let's go back to here. Okay, so we're going to do can date now. Oh, toString. Let's do a toString. Well, so you can also have IntelliJ generate a toString. Oh, that's actually pretty good. They did a good job. Except I don't need it to tell me it's a person. So let's take this part out. But what I mean by this is a good job is it has all the attributes, and it's not just printing name, age, messy, must match. It actually has text that tells me what those values are. So that's why I like it. All right, so that's a good toString. And remember, the purpose of a toString is to have it so that you can put a variable containing your object into a print statement, and it will still print in a way that makes sense. All right, let's actually make a tester, person tester. Oh. And now I'm going to display them side by side. Whoop. Okay, so here's person tester. Let's just make sure that this looks good so far. So person P equals new person. Waldo is 24 and is messy, but doesn't care if the other person's messy. So now let's print Waldo and make sure that that works. Great. Name Waldo, age 24, messy, must match. What I'm doing right now is a great practice. It's called having a short code test cycle, or a short implement testing cycle. So I have not written the difficult parts of this class yet, but I want to test to make sure that what I do have works the way I expect it to work. If you wait till the very end to start testing things, it makes it much harder to figure out where the bugs are. Okay, so let's go back to here. All right, so now we're going to do candidate. So notice the parameter here. The data type is person. So I'm not doing like the other person's age. I'm really taking the entire object that is the other person. And if I want to know what the other person's age is, I can say other.getAge. If I want to know what my age is, the age of the person who is running this code, I could say this.getAge. I think it's slightly better practice to use the getter methods, even though you could access the attributes directly, for a reason that's a little bit hard to explain right now, but I will explain it probably in not too long. Okay, so let's see. The first thing we wanted to do is make sure that I am not too young. So if this.getAge is less than 14, then I can't date anyone, so I'll immediately return false. Otherwise, let's calculate the min age and the max age that the other person could be. So let's get my own age, and let's multiply it by 2, and let's divide it by 2, except I'm not going to integer divide. I'm going to, this is interesting. Let's make this a double, actually, because I don't necessarily want whole number years. We can see. All right, so min age. All right, so I'm going to get my age. I'm going to divide it by 2, and then I'm going to add 7. And then max age, I think it said get age and then subtract 7, and then take that entire thing and multiply it by 2. So you need parentheses here. And so now I want to return whether other.getAge is between min and max. So if min age, so if other.getAge is greater than or equal to the min, and also other.getAge is less than or equal to the max. Okay, great. And you'll notice I'm using this pattern where I'm just returning the thing I'm evaluating directly. You might be tempted to do something like this, which is not wrong. You could say, if it's between the two ages, return true. Otherwise, return false. And that's okay. That's not wrong. But it's just a little bit redundant because this expression is evaluating to whatever it is you want to return. So if this is true, you're returning true. If this is false, you're returning false. So why not just return what that thing evaluates to be directly? That's a little bit shorter. All right. I think that's good. If I was doing a good job here, I would be testing this method right now. But this is one of those do as I say, not as I do things. All right, let's do isMatch. So the first thing I want to do is if this dot so I'm going to run candidate. And if it's not true that this object can date the other object, I will return false right away. You'll notice that I like to test for conditions at the top that would let me exit immediately. Okay, so as long as I know that they can date, now I've got to check the messiness. So let's think this through. So if this dot is must match, so that's my getter method for must the other person match my messiness. So if that equals true, then let's do this sort of in a verbose way. So if that's true, then let's check to see if this dot is messy has the same value as other dot is messy. Okay, so let's implement this like I'm saying in sort of like a big messy way, and then let's clean it up a bit. So if I think that the other person has to match my messiness level, let's check to see if they do, and if they do, great. Otherwise, it's a no-go. Can we say great yet? Yeah, I think we can. If other dot is must match equals true, then same thing. We'll check to see, do we have the same messiness value? If neither of us care, then it doesn't matter, and so we'll return true. Okay, so this works, but I think it's a little bit messy and a little bit redundant. So one thing is you don't have to explicitly test for equaling true. You can just say if this is a must match. So that makes it a little bit shorter. Second, because the inside here is the same, regardless of whether it's us or the other person who requires a match, I can put that in an or statement. So if I think we've got a match, or if the other person thinks we've got a match, so if either of us thinks that we have to be matching, then we do the check to see if we're matching. So now we can eliminate this because we're doing the check. And now we've got the situation where if this evaluates to true, I'm returning true. If this evaluates to false, I'm returning false. So actually, we don't need to do that. We could just say return whatever this evaluates to be. And now this is a little bit shorter. So I'm saying if it's not true that I can date the other person, then we're not a match. If they think we've got to match messiness, sorry, if I think they've got to match my messiness, or if they think I have to match their messiness, then let's check to see if we do match. If we do, great, it's good. If we don't, then we'll return false. If neither of us thinks that we've got to match each other, then this if statement will be false, and we'll just go on and return true. So notice how much cleaner this looks. And this is going to be a big theme of AP Computer Science is your code can become unwieldy, kind of unmanageable if you're always writing it in kind of the longest way that first occurs to you. It really matters to go back and to think about what's the simplest way of expressing your idea. Okay, I think we've done that. So now, let's go back here. Cool. Cool. So now let's make the tester where we've got 100 person objects. We'll randomly generate them. Ages between 12 and 65. Okay. So here we are in the tester. I want to make an array. So the array will hold person objects. So I'll say person array people equals new person array for 100 people. Now let's loop people.length. So let's loop 100 times. Let's create a new person. And the new person will always be called Dr. P. Okay, age, messy, must match, must match. Okay, so let's generate a random age. Well, okay, I was going to write helper methods for everything, but let's not. Let's do this. So age equals int. I said between 12 and what? Did I say between 12 and 65? Yes. So 65 minus 12, but plus 1 for the reason that we talked about a couple of times in this video already. Cool. So the minimum age is 12. The maximum age is 12 plus the difference between 65 and 12, which would be 65 is the largest thing this could be. So there's age. Let's make some random Booleans. So Boolean messy. Here's a good way to think about it. So let's do this. So if Math.random is greater than 0.5, there's a 50% chance that Math.random is greater than 0.5. So in that case, I could say, let's do this. Let's set messy to be false by default. And here, if Math.random is greater than 0.5, we'll set messy to be true. So now messy has a 50% chance of being true and a 50% chance of being false. A shorter way of doing the same thing would be messy equals Math.random greater than 0.5. Because this is a Boolean expression. This is generating a number and asking the question, is it true that this is bigger than 50? Bigger than 0.5. So this has a 50% chance of being true, in which case we'll assign true to messy. This has a 50% chance of being false. So that's, a very kind of short, clean way of doing that. And then let's do the same thing for must match. Greater than 0.5, okay. So then messy and must match. Okay, so now I've made my person, and let's say people I equals P. So I'm taking the person object and storing it in location I as I goes through everything in the list. Okay, so now let's loop through. What did I want to do? I wanted to see who the matches are. Who's a match for the first person in the array? So I'm actually going to get out the first person in the array and call them target. I'm going to call them lucky. So people 0 is the first person in the array. So now let's do a loop starting at, well, we'll change that in a second. So we'll start at 1, because I don't want to match the person with themselves. And since lucky is the person at location 0, I don't want to visit location 0 again. So now let's get out the other person. Possible match equals people I. And now I'll say if lucky dot is match with possible match, then S out possible match. Okay, cool. Ooh, let's try it. Oh, you know what? I want to print out. Oh, there are lots of oldies here. Let's print out. It's unhelpful because they're all called Dr. P. Let's print out lucky person plus lucky, because then we can actually check to see like how old is lucky and is what we're getting making any sense. All right, so Dr. P is aged 55, so we're getting, yeah, a lot of oldies here. Makes sense. Cool. Let's run it again. Age 22, so we're getting, okay, that makes sense. I think that makes sense. I mean, I'm not like obviously calculating out, but I'm just sort of spot checking. Is there anything very unexpected here? So they are messy, and the other person has to be messy. And so you see that in the messy column, everybody is true messy because my target person said that they are messy and the other person has to match them. So that makes sense also. Let's do another one. So they're messy, but the other person doesn't have to match. So whenever must match equals false here, it doesn't matter what this one is. If must match equals true, then the messy value here has to match the messy value there. So anyway, I think this is probably working. This makes sense. Okay, last of all, write a loop for anybody who could date the first person but who is not a match. So let's do that. I'm actually just going to delete this loop. All right, so could date. So if target dot, no, not target, what did I call them? If lucky dot can date possible match, and also it's not true that lucky is a match for possible match. So they could date, but it's not true that they're a match. Then I want to print out possible match. That makes sense. Let's try it. Okay, so let's figure out why did they fail. So could date means they're in the right age range, and that all seems kind of right to me. Messy false. So they don't think there needs to be a match. So here, right, so all three of these people say they've got to match. They've got to match me, and I am messy. Whereas this person is not messy. And so that's why these three failed. That makes sense. All right, cool. This is a fun problem. Well, you know, I thought it was fun. Anyway, I hope you thought it was. If not fun, then at least educational. I will see you in class, in person, but not your mouths. Cool. Bye.